to have the class recorded. All right. So folks, just to remind you this calendar, we do have a test that's due this Sunday on Chapter 9, okay? And that's the only activity due by this Sunday. On Wednesday and Friday, we're going to cover section 10.1. This is called Law of Sines. Now, even though this test really is extended until May 1st, my suggestion would be do this test by Sunday, by this Sunday. This way you don't forget the concepts from Chapter 9. And especially since we're going to review the practice test today, it would be good after today's class to go in and take this test while it's all material still fresh in your mind. Okay? But if something comes up and you can't take the test by this Sunday, April 5th, it'll still be open and available even beyond that due date. Folks, does anyone have any questions on Chapter 9? Any WebAssign homework problems that caused you trouble? Anything like that? All right, well, let's get started then. So here is the practice test that's posted in Canvas. By the way, let me just go back for a second and remind you that in Canvas, here are all the recordings from our online classes. And if I go here to modules and scroll down to module 9, here's the practice test that we're going to go through right now. Here's a summary of all the formulas from Chapter 9. So you are welcome to use this summary when you take the actual test in WebAssign. So I'm going to bring it up and kind of keep it side by side. So here are these formulas from Chapter 9. All right, remember, you don't have to memorize them. You have them all organized on this Chapter 9. All right, so does anyone have any particular problems in this practice test that we should jump to? Otherwise, we'll go in order.
Well, we'll go in order.
All right, let's do it. Let me start with number 1. So this number 1 is asking you to take a messy trig expression and try to simplify it somehow. Notice it says use the fundamental identities. Well, the identities are these identities that are here on the right-hand side of the screen. Right? They're called reciprocal identities, Pythagorean identities. So they're asking us to try to rewrite this expression and make it much simpler. Maybe this is just going to simplify down to sine of x or cosine of x or 1 over cosine x, something like that. So here's the game plan for these kinds of questions. You would like to change all trig functions to sines and cosines. Because if you could do that, sometimes you'll be able to cancel out trig functions, or sometimes you'll recognize that what you're left with matches one of these identities. For example, if I was left with an expression like sine squared plus cosine squared, I know I can replace that with just 1 because of this famous identity that says sine squared of an angle plus cosine squared of an angle equals 1. All right, so that's the idea. Also, if you ever see a negative angle in these expressions, you want to get rid of negative angles and write the trig functions only using positive angles. And that's what these identities will let you do here. All right, let's get started. I'm going to change each one of these trig functions to the equivalent sine cosine version. All right, let me start out here with cotan. Well, I'm coming over here and I'm seeing that cotan is cosine over sine. So I'm going to write this guy as cosine over sine. Okay. Next is a cosine. But I'm just going to bring that down with me because remember, I want everything to be in terms of sines and cosines. Okay, let me come over to cosecant. Well, I want to get rid of cosecant. And to get rid of cosecant, I'm noticing here cosecant is 1 over sine. So I'm going to make that 1 over sine times sine squared. All right, but I still want to keep going because this isn't as simple as it could be. Now, if you look at the second part here, you might be tempted to cancel out a sign on the bottom with a sign on top here. But I'm not going to do that. I'm not going to cancel out signs in the second expression. Why not? Why wouldn't I cancel out sign? I am allowed to do that, but why would I not want to do it here? Well, the reason is I'm noticing this first expression is also over sine. So I really want to be able to add these two fractions together. So I do want the same denominator. Remember, to add fractions, you must first have the same denominator. So I'm going to leave both of these fractions with the denominator sign. This way I can add the fractions in a second. All right, well, let me clean this up a little bit, though. Here, this is a cosine times a cosine. Well, that's a cosine squared. So that's going to be cosine squared over sine. And then on the right-hand side, I'm just going to write this as sine squared over sine. All right, now I can add the fractions, because remember, I do have the same denominator. The way you add fractions when you have the same denominator is you keep the denominator as is. So I'm going to leave sine on the bottom, and you add the numerators together. So that means I'm going to add together cosine squared plus sine squared. And now I'm almost done. I'm noticing that this numerator matches one of the identities, right? Because this numerator is this famous sine squared plus cosine squared, so the numerator is just 1. So I end up with 1 over sine x. That would be a valid answer. Or if you wanted to, I know that 1 over sine is the same as cosecant. So I could write this if I wanted to as cosecant x. Either one of those answers would be okay.
Oh, when I took it when I did this question before, like a couple days ago, I got 1 over sine x as my answer.
Yeah, that's exactly right, Gennaro. Yep, exactly.
Like,
All right,
Web
folks.
will take it then if it's on the test.
Yeah, WebAssign should take it. By the way, folks, a general comment: if you think you've entered an answer that WebAssign should be accepting, but WebAssign marked it wrong, please email me or contact me so I can take a look at it. And I'll give you credit, of course, if you really do have a correct answer there. All right, let me go to number 2. Number 2 is going to be the same idea. We want to get rid of any trig functions that are not sine and cosine and replace them with sines and cosines. But I also want to get rid of negative angles. So to start with, let me come here and notice tan of negative x. But when I come over here, it says tan of a negative angle is negative tan of the angle. So I can make this tan a negative. So let me do that. I'm going to write it as secant x. And I'm going to put the negative sign up here as a subtraction. So I'm going to write it minus sine x tan x. So notice we got rid of the negative angle, and now the tangent is based on a positive angle. All right, so that was step 1, just to get rid of that negative angle. Now let's convert all of these trig functions to sines and cosines. Secant, I know, is 1 over cosine. So I'm going to write this as 1 over cosine. Minus sine, I'm just going to leave alone because I want the expression to contain sines and cosines. But tangent, I'm going to replace. And I notice here that tangent is equal to sine over cosine. So I'm going to make it sine over cosine. All right, well, I'm noticing this is a subtraction, but the good news is it looks like I have the same denominator to do the subtraction. So I'm very excited about that. All right, so let me write this as 1 over cosine. Write it up here. 1 over cosine. And in the second fraction, I have a sine times sine. So I'm going to write it as a sine squared. And this is over cosine. But I have the same denominator, so let me do the subtraction, keep the denominator the same. Subtract the numerators, 1 minus sine squared.
Is that the answer?
Well, I think I could go one more step, Gennaro. Here's why. When I look at the top of this fraction, I'm seeing 1 minus sine squared x.
Yeah.
Well, that kind of looks familiar. Let me go back to this famous Pythagorean identity. Well, the famous Pythagorean identity is sine squared plus cosine squared equals 1. I'm going to take this famous identity and I'm going to subtract sine squared from both sides. The reason I'm doing that is now I notice that this is going to match my numerator. This is going to cancel out. So I'm ending up here with cosine squared is 1 minus sine squared. But 1 minus sine squared is exactly what I have on the top of this fraction. So it looks like 1 minus sine squared can really be replaced with cosine squared. So now I'm left with cosine squared x over cosine x. But of course now the cosine, one cosine will cancel out. And the final answer here is?
Cosecant.
Well, one cosine on top will cancel the cosine on the bottom, leaving just the cosine. So this answer is just cosine x.
But when I did it, like the first one I got, the answer is cosine x. That's what I got.
Yep, exactly right. All right, folks, these are a little tricky because you've got to kind of do some algebraic substitutions here.
But then like on the last questions, I'll get easy then.
Yeah, some of these are definitely easier than others, but you just have to follow the same general procedure, which is replace cosecant or tangent or cotangent, replace any of those with their equivalent expressions, but using sines and cosines.
Let's do number 3.
Let's do number 3. This one is a little more complicated. So let's take a look at this one. Now for this one, notice they're saying to me, simplify the first trig expression and write it in terms of the second trig expression. So what they're trying to say here is once you're done, your answer should involve cosine x only. Your answer might be cosine x, your answer might be 1 over cosine x, your answer might be cosine squared x, but somehow your answer should use cosine x. All right, well, let's go ahead and set this up by replacing each one of these trig functions with their equivalent. All right, tangent I know is sine over cosine. Okay. Cotan I know is cosine over sine. Okay. And on the bottom of this fraction, I have a cosecant. Well, cosecant is, so now I'm going to replace the cosecant on the bottom, but I know that cosecant is 1 over sine. So this cosecant, I'm going to replace with 1 over sine on the bottom. All right, well, this is a pretty messy fraction, but it is one fraction divided by another. So whenever you have one fraction divided by another, you leave the top fraction alone, change to a multiplication and flip the bottom fraction upside down. So I'm going to take this guy and flip it upside down and write it as a multiplication. So that's going to be sine x over 1. Whoops, I have a typo here. I just realized. This should be cosine over sine here. Let me fix that. That should have been cosine over sine.
What should be cosine over sine?
This, when I wrote cotan here, cotan of x.
Yeah.
Let me come over here. Cotan is the cosine over the sine.
Yeah.
So I have to write it here as cosine over the sine. I had a typo, but I just fixed it.
Okay.
All right, so now I flipped the denominator, which is 1 over sine x. I flipped it upside down to be sine x over 1. All right, now let me go ahead and multiply. Well, I'm going to take this sine x and let it multiply inside the parentheses like a distributive property. All right, so let me do that. So I'm going to end up with sine squared x over cosine. Let me explain how I got that. I'm multiplying this cosine back here. Let me circle it in purple so you can see it. I'm multiplying this sine in purple inside the parentheses like a distributive property. So when I multiply that sine in purple times this sine here, I get sine squared. All right, now let me go to the back of this fraction. Now I'm going to multiply sine x times this second expression. That's going to give me a sine cosine over sine. All right, well, I'm looking here at these fractions, and I don't have the same denominator. So, you know, in the previous examples, I didn't cancel because I wanted to keep the denominators the same. But I don't have the same denominators here, so I am going to cancel. This sign cancels out with that sign. All right, so what I'm left with now is sine squared over cosine plus a cosine x. All right, I want to add these fractions together, but I don't have a common denominator yet. So let me try to get a common denominator. Well, to get a common denominator, I want the second expression, you know, I can write this as cosine over 1. I want this guy to have a denominator of cosine. So I'm going to multiply this back fraction here by cosine over cosine. The only reason I'm doing this is to get the denominator I need. Okay. Let me scroll down a little bit here if I can. So let me do this. Let me continue it over on the right-hand side. All right, let me continue it over here. So if I keep going, the first fraction is still sine squared over cosine. But now let me go back, let me go to this back fraction. On top, it's cosine times cosine. That's cosine squared. And of course, the denominator is cosine. Now I can add the fractions because I do have the same denominator. So the rule is keep the denominator as is, but add the top together. But of course, on top, it's going to be sine squared plus cosine squared. But that's the famous identity, sine squared plus cosine squared is 1. So the answer here is just 1 over cosine x.
For number 3, when I did it, I got 1 over cosine x. That's what I got.
Yep, that's it. And notice my answer does contain cosine x, just like the instructions wanted. Folks, any questions here on 1, 2, and 3? These are all similar in the sense that you've got to do trig substitutions.
Can we do number 4?
To do this, to get the expression as simple as possible.
Can we do number 4?
Let's do number 4, yes. All right, let me scroll down here. All right, let me go to number 4. So number 4 here says find the exact value of sine 7 pi over 12. So you might think, well, let me go to the unit circle and just look up sine of 7 pi over 12. But
it doesn't say it over there.
Right, the unit circle doesn't have 7 pi over 12, so that's not going to work. I need another method. Well, the other method is to write this as the sine of 2 angles being added. So I'm going to try to write this as sine of A plus B, where A and B are on the unit circle. If I could do that, then I'm going to come over here to these identities that will let me work out the sine of A plus B, the sine of A minus B, cosine A plus B, and so on. All right, now one thing I could do here to make things a little easier is instead of working in radians, it might be easier to work in degrees. Because when I want to come up with the sum of 2 angles, I think it's easier to be in degrees than radians, but of course you could do it either way. So let me change 7 pi over 12 into degrees. So you might remember from the beginning of the class to change radians to degrees, you multiply by 180 degrees over pi radians. And I remember to set the fraction up this way because I know I want the radians to cancel out. So I put the radians on the bottom here to cancel out with the radians on the top. But also have a pi, top and bottom, that I can cancel out. So I'm going to cancel that out. Let me do one other canceling just to simplify fractions. I'm noticing I have a 180 on the top and a 12 on the bottom. But 180 divided by 12 turns out to be 15. So this is really going to cancel out, leaving me with a 15. So I'm left with 7 times 15. And 7 times 15 is 105. So I know I really want to find the sine of 105 degrees. So I'm looking to figure out sine of 105 degrees. But again, 105 degrees is not on the unit circle. I want to come up with 2 angles that are on the unit circle that add to 105. Can anyone think of 2 angles that add to 105 degrees, and those 2 angles are on the unit circle?
70 and 35.
70 and 35 would add to 105, Gennaro, but 70 degrees is not on the unit circle. Notice here, 70 is not on the unit circle.
Well, 60 and 45 then.
60 and 45 would do it. By the way, folks, there's usually more than one answer here. So just because we use 60 and 45 here, it doesn't mean you have to use the exact same angles. There's typically more than one way to set these up. But let's use 60 and 45. I think that's the most obvious. All right, well, now we have sine of A plus B. So now I'm going to use this identity. In our example, alpha is this 60 degrees, and beta is this 45 degrees. So now when I write it out, I'm really just going to copy the right-hand side. So it's going to be sine alpha to begin with, but that's sine 60. Okay, that was this guy. Let me come over next is cosine beta. Well, our beta is 45 degrees. So I'm going to write that as cosine 45 degrees.
And plus over there.
Now I'm going to put a plus here. Now I need cosine alpha.
Cosine 60.
Yep, our alpha was 60, so that's going to be cosine 60. And finally,
45.
the last part of this is sine beta, but our beta was 45 degrees, so sine 45 degrees. All right, well, the good news is all of these angles are on the unit circle, so I can really just plug in for each one of these.
1 over
All
2
right.
for cos. 1 over 2 is that's for cosine. 1 over 2 for 60.
Yep. Let's come here to sine 60.
Square root of 3 over 2.
Yep. The sine is the y value, so that's square root of 3 over 2.
And cosine 45 is square root of 2 over 2.
And let's go to cosine 45. Here's cosine is the x value, so here's cosine 45 square root of 2 over 2. And now let me go to the back of this. Now I have cosine 60.
Which is 1 over 2.
Here's cosine 60, 1/2. And finally, sine 45. That's the y value square root of 2 over 2. All right, now I'm basically done, but I'm just going to multiply these fractions across. So I'm going to end up with square root of 6 over 2. Excuse me, over 4. Square root of 6 over 4. And back here, when I do this multiplication, it's going to be square root of 2 over 4. I could leave my answer like this, or if you wanted to combine these fractions together, because they have the same denominator, I can write it as square root of 6 plus square root of 2 all over 4. Right, so this answer is okay, or this answer is okay. Remember, don't work this out on your calculator to get a decimal answer, because WebAssign said find the exact value. All right, so the trick to this one was, because the angle they gave me was not on the unit circle, I had to try to rewrite it as the sum of two angles that were on the unit circle. We came up with 60 plus 45, and then we plugged into this formula for sine of a plus b.
What I got right here, square root of 6 plus square root of 2 over 4. That's what I got.
Yep, that's our answer right here. Good. All right, folks, let's go to number 5. By the way, folks, I want to mention, if we don't finish today, we could still do more of these examples on Wednesday. But let's keep going. Let me go to number 5. Number 5 is going to be a similar example to what we just did. I'm noticing number 5 is asking me about the cosine of one angle subtract the second angle. So let me go to my formula sheet here, and I'm looking for cosine of one angle subtract the second angle. Well, notice right here, it's cosine of a minus b. All right, so let me just match up the angles here. And I'm noticing that alpha matches up to x and beta matches up to 4 pi over 3. So let me plug into the right-hand side of this equation then. All right, it says I should write cosine alpha, but our alpha is x.
Just
So
say cosine of x.
Cosine x. Next is cosine beta, but our beta is 4 pi over 3. Okay. Now I'm going to write a plus sign down. The formula tells me to use a plus sign. Be careful. You might think that you should use a minus sign because, you know, this was cosine alpha minus b. But no, it's a plus sign. So I got to copy down the formula carefully with a plus sign. Next, it wants sine alpha, but our alpha was x, so that's going to be sine x. Finally, I need sine beta, but that's sine 4 pi over 3. Okay, I'm almost done. All I have to do is go to the unit circle and look up these results. Now, cosine x, I really can't change or simplify because I don't know what angle x is. So I'm just going to copy down cosine x as is. But cosine 4 pi over 3, I can look that up on the unit circle. So let me go look that up on the unit circle. Go back to the unit circle here. So let me look for cosine 4 pi over 3. And if you look on the unit circle, you might notice down here is the angle 4 pi over 3. I need the cosine, which is the x value. So this is going to be negative 1/2. All right, let me go to the back. Sine x, I just have to copy down. Can't do anything with that.
Yeah.
But sine 4 pi over 3, of course, I'm going to look that up on the unit circle. And when I go to the unit circle, it looks like that is negative square root of 3 over 2. And that's the answer. I could just leave the answer like this. And WebAssign should be happy.
That's the answer?
This is the answer. I can't do anything else because I can't really simplify cosine x and sine x. I just have to leave those as is.
Wait, I got the answer as negative 1 over 2 square root of 3 sine x, then minus cosine x over 2.
Yeah, so Gennaro, you just flipped this around and you wrote it with the sign in front. So Gennaro, you could write it, of course, like this. Minus square root of 3 over 2 sine x minus 1/2 cosine x. That would be exactly the same.
So like
Either
we'll take either one then.
WebAssign will take either answer, yes. All right, folks, how about if we do one more example like this?
Number 6.
Number 6 is especially complicated. And folks, you know, when you go to take the test in WebAssign, remember it's timed for 2 hours. So you really have to know these concepts going in. You can't expect to learn them while you're taking the test. You'll run out of time. So that's why it's important to have this practice test worked out ahead of time so that you can be efficient when you go and take the real test in WebAssign that's timed at 2 hours. All right, so how about if we look at number 6? All right, and number 6 is a bit tricky because it wants to know sine of a plus b, and they're giving us a few values, but they're really not giving us everything that we need to plug into the formula for sine of a plus b. So we're going to have to do some extra work ourselves. All right, well, they want to know sine of a plus b. So that means I really need 4 parts. I need this part, this part, this part, and this part. Well, there is good news. I do know sine of a. So this is given. I know that's 3/4. That was given to me in the problem, right? Sine of a is 3/4. The other good news is I know cosine b. That was given to me in the problem. That was negative 1/5. Okay, here's the bad news. I don't know cosine a, and I don't know sine of b. Those were not given to me in the problem. So I need to figure out cosine a and sine b myself so I can plug into this formula. All right, well, to do that, I'm going to use the famous sine squared a plus cosine squared a equals 1. Remember, this identity is important because it says if you know the sine of an angle, you can figure out the cosine. If you know the cosine, you can figure out the sine. Even if the angle's not on the unit circle, you could still figure it out. All right, so let's go ahead and let's figure out cosine A to begin with, because I need this cosine A. So I'm going to use the fact that sine squared A plus cosine squared A equals 1. But I know that sine A is 3/4. So I'm going to plug here 3/4 squared plus cosine squared equals 1. Now I need to solve this equation for cosine. So let me do the squaring to begin with. 3/4 squared is 9/16. So now I have 9/16 plus cosine squared equals 1. Well, I want to get the cosine squared by itself. So I'm going to subtract 9/16 from both sides of this equation. Now on the right-hand side, for me to do this subtraction, I have to change this 1 to have a denominator of 16. So I'm going to rewrite the number 1 as 16/16, because that'll get me the common denominator I want. All right, now I'm left with, I'll write it up here, looks like I'm left with cosine squared A equals, and when I subtract these fractions, keep the denominator as 16, and on the top, 16 subtract 9 is a 7. All right, so I have cosine squared of A is 7/16. But I want cosine A, so I'm going to take the square root of both sides. So cosine A is going to be the square root of 7/16. But remember, I got to put a plus or minus in front. All right, well, finally, to make this as simple as I can, I'm going to take the square root of top and bottom separately. So it's going to be the square root of 7/4. Because when I take the square root of 16 in the denominator, square root of 16 is just 4. Should I use the plus sign or the minus sign here? Should I make this answer be a positive answer or a negative answer? Well, for that, let me go here to the interval they're telling me. So they're telling me these angles are in this interval from pi over 2, here's pi over 2, to pi. But this interval is quadrant 2 on the unit circle. Let me think back to whether the trig functions are positive or negative. Remember, all students take calculus is one way to remember this. So in quadrant 2, the sine is positive, but the cosine is negative. You can also tell that just by looking at the unit circle. If you go up into quadrant 2 in the unit circle, you'll notice that all the y values for the sine are positive numbers, but all the x values for cosine are negative numbers. Well, that means that this cosine answer should be negative because we're in quadrant 2. So I can drop in now that cosine alpha is negative square root of 7/4. All right, let me go to the other piece of the puzzle. How about sine B or sine beta? Well, I know cosine B, and I'm trying to figure out sine B. So for that, I'm going to use sine squared B plus cosine squared B equals 1. All right. I know cosine B is negative 1/5, so I'm going to drop that in here. Negative 1/5 squared. And let me square negative 1/5. That's going to be then 1 over 25. but I want to get the sine squared by itself. So let me subtract 1 over 25 from both sides. And I'm going to change the number 1 to be 25 over 25 to get the same denominator that I need. All right, let's see what's left over now. On the left side, adding 1 over 25 and subtracting 1 over 25 cancels out. I'll write it over here. That means we have sine squared b equals, when I subtract these fractions, on top it's 25 minus 1, which is 24, 24 over 25. I'm going to take the square root of both sides. So sine b is going to be the square root of 24. And when I take the square root of 25 on the bottom, that leaves me just a 5. Should I make this answer positive or negative here? Well, I know in quadrant 2, the sign is positive. So I'm going to leave this as a positive answer. So finally, I figured out sine b. It's the square root of 24 over 5. All right, I could leave my answer like this if I wanted to. If I wanted to clean it up one more step, I can multiply these fractions together. So this would be negative 3 over 20, just multiplying the fractions together. And then this is going to be minus, and when I multiply the square root of 7 times the square root of 24, that gets me the square root of 168 over 20. Could leave the answer like that, but if I wanted to actually subtract the fractions, because I now have the same denominator, I could write 20 as the common denominator and negative 3 subtract the square root of 168. And I could leave the answer like that. So this was a messy problem because you had some intermediate steps to work out.
Actually, yeah. We actually says here for cosine, then you have to do sine A plus B and cosine A minus B. For cosine A plus B, I got 1 over 20, then negative 3 plus 2 square root of 42. Then for cosine A minus B is 1 over 2 minus square root of 7 plus 6 square root of 6.
All right, Gennaro, you might be simplifying this square root of 168.
Yeah.
Which is perfectly fine to do it that way. It turns out the square root of 168 can be simplified. Because we could pull out the square root of 4 from that. But I'm just going to leave it the way it is. But you can do more simplifying if you want, okay? Now, we didn't do cosine A minus B yet. And I'm going to skip over that unless someone has a question. For cosine A minus B, that's going to be a lot faster. I'm going to use this formula, but I already have all the ingredients worked out. Because now I know sine A, sine B, I know cosine A, cosine B, so now that's just going to be a matter of plugging it in. So part A of this problem really involved a lot of the work to solve the problem. All right. Folks, how about if we do a few examples that are different? So how about if I go to number 7? And now number 7 is a different problem because notice it says sine of 2x. Well, here are some formulas that we call double angle formulas. So anytime you have sine of 2x or cosine of 2 theta, we're going to use these formulas. All right, so they want me to figure out sine of 2x. Well, here's the formula I need for sine of 2x. So this is going to equal 2 sine x cosine x. All right, well, the good news is sine x I know, because that was given to me in the problem. Sine x was given as 1/4. The bad news is I don't know cosine x. So again, I have to go off to the side and do the sine squared x plus cosine squared x equal 1 routine. Because now that I know sine, I can use this formula to figure out cosine. Let's do it quickly. So the sine is 1/4. I'm going to square that. 1/4 squared is 1/16. Now I'm going to subtract 1/16 from both sides. And of course, when I do that, I'm going to make the right-hand side, I'm going to change 1 to be 16/16. Okay, now let me do the subtraction. Of course, that part cancels out. It looks like I'm left with cosine squared equals 15/16. I'm going to take the square root of both sides. When I take the square root of both sides, I'm left with the square root of 15/4. The reason I'm putting a 4 on the bottom is when I took the square root of 16 in the denominator, that left me with just 4. Normally, I would put a plus or minus in front here, right? Whenever you take the square root of both sides like this, you have to put a plus or minus. But I know that we're in quadrant 1. Well, in quadrant 1, I know that the cosine is positive, so I'm going to change this to just be a positive value. All right, well, I have cosine x, so I'm going to drop that in now. So this is the square root of 15/4. Now I could just multiply these fractions across. This looks like 2 square root of 15. And then there's a 4 times 4 on the bottom. That's 16. But I can simplify this fraction 2/16 and just write it as the square root of 15/8. So that's the answer for part A. Okay. Let me just mention part.
Cosine.
Yeah, go ahead, Gennaro.
Let's find the cosine.
Cosine. Cosine, I could use either formula A, B, or C. That's totally up to me. So how about if we use formula A? So if we want cosine 2x, maybe I'll try to write it up here. Cosine 2x for part B of this problem. I'm going to use formula A, but of course you could use any of these 3 cosine formulas, you get the same answer. So I'm going to use cosine squared minus sine squared. All right, well, in our example, we figured out the cosine. Right, our cosine was square root of 15/4. So that's going to be the square root of 15/4 squared minus the sine squared. But the sine was 1/4, so that's going to be 1/4 squared. All right, now I'm just going to clean this up. The square root of 15 squared is just 15. And then when I take the 4 squared on the bottom, that's a 16. And then in the back here, 1/4 squared is just 1/16. So I'll just subtract these fractions. That looks like 14/16 or 7/8. All right, so we have part A and B.
Now we need tangent. Now we need.
Yeah, let's go to part C and take care of tangent 2 theta or tangent 2x. Now I could use this formula down here.
That's the only formula they have.
Yeah, but there's actually another formula that I could use, Gennaro, because anytime I want to know the tangent of any angle, The definition of tangent is take the sine of that angle over the cosine. So here's an alternate formula for tan 2x. It's just going to take the sine over the cosine. The reason this is nice to use this format is I know sine 2x and I know cosine 2x because I just figured those out a minute ago. So I might as well reuse those answers. Remember, sine 2x was the square root of 15 over 8. And cosine 2x was 7 over 8. All right, so now it's just one fraction divided by a second fraction. To work this out, you leave the first fraction as is, change to a multiply, flip the second fraction upside down. All right, the good news is the 8s cancel out top and bottom. So it looks like the final answer here is the square root of 15 over 7.
That's what we get for the tangent.
Yep. So this is the answer to part C for tangent 2x. I made use of sine 2x and cosine 2x to get this answer because I had those results already from parts A and B of this question.
Let's check number 8.
Well, Gennaro, I'm going to let some students drop off if they want because we're just about out of time.
So we'll do Wednesday then.
Let's do the rest of these examples on Wednesday. Folks, please look over this practice test. So on Wednesday, we can be sure to cover those examples that you might have a question on.
Yep.
All right, so on Wednesday, we'll finish this practice test and we'll get started in chapter 10 with section 10.1. All right, folks, if you get stuck on any of these practice exam questions, please email me ahead of time. This way I can clarify things before our next class meeting. All right, folks, thank you for joining. See you on Wednesday, same time. And please let me know if you have any questions.
All right.
And folks, I'm going to stick around for a couple of minutes in case anyone has a question. Otherwise, if you don't have questions, feel free to log off.
Wait, for number 8 right there, it says the angles of Pythagorean theorem.
Gennaro, let me scroll down to number 8. We'll take a look at it here. Gennaro, number 8 says, use the figure below to find the exact values here.
So first of all, we're going to be finding for sine of 2 alpha.
Yeah, we're actually going to find just the sine of alpha to begin with. So we're going to find the hypotenuse of this triangle. To find the hypotenuse, you can use Pythagorean theorem, right?
Okay, alpha 75. Then you have to do for a sine. You have to do a opposite over hypotenuse for sine.
Yep, that's right. So the sine of alpha is opposite over hypotenuse, which is 75 over 85.
75 over 85. Yep,
Right.
that's right.
Because this is the opposite side.
And the hypotenuse is 85.
And the hypotenuse is 85, yep.
And then 40 is the adjacent.
Yep, cosine alpha is adjacent over hypotenuse. So that's going to be 40 over 85.
Cosine, it says 2 alpha.
So now we want to figure out sine 2 alpha. Well, I'm going to come over here to this formula that says to figure this out, I'm going to use the formula that says 2 sine alpha cosine alpha. but I know sine alpha and I know cosine alpha, so now I can just plug these in. I might want to simplify these fractions though before I do it, because I'm noticing this is really going to be 15 over 17, I think. I'm just simplifying these fractions by dividing top and bottom by 5.
And don't forget about the tangent for tangent of alpha.
Yeah. So let me plug in sine alpha is 15 over 17.
15 over 17. And times
Times cosine alpha,
8 over 17.
8 over 17. Now I can just multiply this all out. On the top, I think I end up with 240, multiplying all the numbers together.
Over 289.
And on the bottom, 17 times 17 is 289. Good.
That's for sine. Now the cosine, we have to do adjacent over hypotenuse.
Well, we do know cosine alpha already, but I need cosine 2 alpha.
This is right here.
So for cosine 2 alpha, I can use any one of these 3 formulas, totally up to you.
We'll use the first one we could use.
Let's use the first one. So the first one says take cosine squared alpha minus sine squared alpha. All right, well, let's work this out. We know cosine alpha, that was 8 over 17, but I have to square it. And sine squared, I know sine is 15 over 17, so I have to square it. All right, when I square these, it looks like it's going to be 64 over 289 minus 225 over 289. And same denominators, keep the denominator and subtract the numbers on top. Looks like I'm getting 161 on top, negative.
Then the tangent of 2a, tangent of 2 alpha.
Right, now for tangent 2 alpha, I could use this formula.
Yep.
But this is messy. There's a better way, a shortcut.
Oh, we forgot to do tangent alpha. We forgot to do.
We actually don't need tangent alpha, Gennaro, but let's figure it out while we're at it. Doesn't hurt.
Yeah.
So let's do tan alpha. Well, the tangent is opposite over adjacent. So the opposite side was 75. The adjacent side was 40. So this would be 75 over 40.
Then the 75 will be 15. Then the 40 will make it 8 then.
Good, 15 over 8. Yep. All right. So I could plug into this formula here if I wanted to. Because now I know tangent alpha. But, Gennaro, here's the shortcut.
Yep.
I'm going to use the fact that tan 2 alpha can also be written as sine over cosine of the same angle. So that means it's sine 2 alpha over cosine 2 alpha. The reason I like this formula better is sine 2 alpha I already know from part A of the problem. Cosine 2 alpha I already know from part B of the problem. So I'm going to reuse my answers. Sine of 2 alpha was 240 over 289.
Then
Cosine 2 alpha on the bottom was negative 161 over 289. All right, well, the way to divide fractions is leave the top fraction alone, change to a multiplication, and flip the bottom fraction upside down. So I'm going to flip the bottom fraction upside down.
And the 289s cancel off.
Yes, the 289s cancel out, which is very nice.
Then you get 240 over 161.
Yep, and the answer is negative, right? Because I have a negative on the bottom, so I'm going to make this answer negative. It's the same answer you would have gotten if you plugged into this formula here on the right-hand side.
Yep.
It might have just taken you a few minutes longer to do it that way.
Okay.
So whatever method you prefer.
All right. Those are the answers.
All right. Sounds good, Gennaro. Let's get together again on Wednesday. We'll finish up this practice test.
Okay.
All right. Thank you for joining. Bye.